In this video, you're going to learn how you can build a complete MCP application that integrates with a local AI agent using Ollama, and we're going to go through what MCP is and how you can integrate it within your AI applications. Hey everyone, my name is Venerin, and in this video we're going to build a complete MCP application that allows you to manage your to-do list using an AI agent. We're going to be using Ollama, Langchain, and the official MCP SDK in order to wrap everything together into a simple UI using Streamlit. Let's get started. The complete source code along with a text tutorial is available for ML Expert Pro subscribers here within the V2 Preview Bootcamp section. Within the bottom side, you can find the new tutorial that allows you to go through all of the examples and explanations that I'm going to go through this video, along with a link to the GitHub repository for the project. So if you want to get access to the source code along with all of the available projects, subscribe today. Model Context Protocol has become a lot more popular than it was first released. So we're going to go through a bit of information about it, what it is, what problem does it solve, and how it can be useful for you. So the main problem that the protocol solves in an interesting way, I would say, is the fact that when you're building AI applications and when you're connecting your LLMs, for example, to tools and external resources, you probably need to write the tooling and the whole integration within the external services, for example, GitHub, Slack, and other services on your own. And when you're doing that, you probably need to have some sort of expertise in order to provide the correct tooling plumbing to your LLM in order for your agents, RACs, or workflows to work correctly. So this protocol was first introduced by Anthropic in almost 6-month-old now blog post, and here you can see the date, and this is available on the Anthropic blog. And what MCP is, or Model Context Protocol, essentially it is an open standard that allows you for your AI models to connect to external applications, and the main components of this protocol are a host application. The probably most common example that you have probably seen is an IDE such as Cursor or VS Code, Windsurf, or something else. Of course, in our example, we're actually going to be building a custom AI agent that is going to be using the MCP protocol to connect to an external application. And then you have a client. This client is going to be provided by the SDK that is going to be available to us, provided by Anthropic. And then we are going to be also having this component, which is a server. So in essence, we have client and server communication that is using a standardized approach. In this case, this approach is going to be provided by MCP. So what this protocol looks like and how it can be useful to you, at least at the start of when you were using your AI applications, you essentially had to write all of the custom code necessary in order to connect to external systems. For example, here you might have something like an SQL database. And from there, you might need to write some tooling for your AI agent. For example, if you were using an LLM such as ChatGPT or Gemini, in order to continue working with a specific file system, you again needed to provide the tooling and the necessary code in order to make that integration possible. Of course, you would expand this to external APIs such as Slack, GitHub, or Google Drive, or other APIs that you might be using in order to complete your job as an AI agent developer, if you will. And this was pretty much good as long as you knew the insides and outs of the external systems and you were integrating correctly all of the tooling and the necessary codes that you need to do in order to provide the best possible tooling and resources to your AI applications. So after MCP is now available, you essentially get an abstraction on top of these custom code bases, which I'm going to show you. There are a lot of examples of those that are both provided by Anthropic and the representative companies that are providing these MCP servers that you can plug directly into your AI applications. And essentially what you can think of as MCP is a USB adapter to your AI applications. In a sense, this client and server that is using a custom MCP protocol, which is actually a JSON RPC under the hood. Then based on this standardization or unification, you essentially get a way to query or use tooling and resources and other essentially stuff from external systems. So how this works in practice and how it can be useful for you. What you get from the MCP servers or MCP applications are three main things. The first one is going to be a resource, and when we're talking about resources, you can think of them as a context for your applications. So this is slightly similar to GET requests in REST applications, and here we have a MCP decorator.resource. And here you can pass in a path to the resource that you want to access. This path is going to be actually give you this user ID, which is going to be mapped right here, very similar to what you have within a fast API application if you were building those. And based on that, you can probably provide a more specific example of what user resource you can provide to the application. And in this example, you can see that we are actually returning just a string for the purposes of this demo. And then you also have an access to tools, which arguably are the most important part that this protocol is providing. So the tooling again is very similar to the resources. You're using this decorator MCP tool, and then you provide a function with parameters and essentially a result that is going to be given to the consumer of your MCP server. And in this example, you can see that this is pretty simple. And here you would ideally want to provide some documentation for the tool itself that will be essentially given to the client that is using the MCP tool. And the next thing that we have are prompts. Of course, you know already what prompts are, but those prompts can be essentially used in a bit more, let's say, customizable way. For example, you might provide parameters that are going to be customizing the prompts based on the parameters. So essentially what you can get here are prompts that are dynamic and provided by the servers instead of the consumers of those tooling itself. So these are the primary things that you get, and how this works under the hood is in two stages or two steps. The first one is the initialization or the handshake. Here the process is actually getting to know both the client and the server as they connect or do their handshake. Essentially, what is happening under the hood is both are specifying what are their capabilities and what resources do they have available. For example, on the server, he might say, hey, I have these resources, I have these tools, and I have these prompts that are available. Also, the client can say, okay, I'm using the MCP protocol version, etc. And then based on the versioning, you should probably get to understand what are the capabilities of both the server and the client. Once this handshake is complete, you are essentially in the stage of where you can send messages between the client and the server. And here, this protocol in particular is using JSON RPC. This is a very old format that is available to other protocols as well. But the guys from Anthropic has chosen this protocol, and I would say that it is a very good choice for it. Here you can send requests, get responses, and sometimes you also can get notifications. So essentially this is a two-way communication between the client and the server. And of course, the transportation between the client and the server is supporting two different approaches. For example, if you're running your MCP instances in a local environment, that is, the client and the server are on your local machine, then you can use a standard input and output in order to communicate between the two. But in practice, and probably the more useful one, is using the streamable HTTP or server-sent events. In this case, the protocol is working over HTTP and resembles somewhat of a REST API. Of course, not exactly, since we're using server-sent events and JSON RPC for the communication itself. Of course, this is allowing streaming of the responses as well, which is cool if you are working with production-grade applications. There are a lot of MCP servers that are available, and most of them are actually provided by the community. The community is already embracing the MPC protocol by a lot. One thing that I would say here is that the servers that are provided as open source are of varying quality. And you can get into the position that, for example, if you want to use the GitHub MCP server, you might get implementations from multiple people that are, again, of varying quality. And based on that, you need to choose actually which servers are the best for your use case. Of course, security comes in mind when using those types of existing applications and servers. So keep that in mind. And probably you need to have some good understanding when picking those servers, what is happening under the hood. We've seen what MCP is, and you might be asking yourself, okay, why wouldn't just I be creating, for example, some sort of simpler tool calling and just call it a day? Well, of course, this could be the case, and in some applications you don't need MCP at all. But one of the great things that I found about MCP is that since it is standardized, you can essentially grab a tool of the internet, for example, a GitHub MCP server, and integrate it within your AI applications using a standardized approach that the MCP protocol is providing you. Of course, this protocol will probably evolve. MCP is not a silver bullet. There are a lot of negatives, and if you're deploying real world or production grade applications using MCP, you will most probably get hit by a lot of pain points. Recall that this protocol is quite new and some of the stuffs are not streamlined yet. And for example, one of the interesting things here is that you might need to manage your MCP server applications in production. So for example, you might Dockerize them using Kubernetes or something else in order to deploy even the MCP servers. Of course, they come with their own dependencies, and you will need to update and manage the security issues around those packages as well. Probably the best resource to learn more about MCP is modelcontextprotocol.io. Here you can find the complete documentation along with a lot of tutorials that include the Python SDK, the one that we're going to be using today, along with the official TypeScript SDK, Java SDK, Kotlin, and C#. Of course, those are the official SDKs provided by Anthropic, and there are numerous others that are provided by the community as well. I have the code for the project open in my Visual Studio Code instance, and here you can see the structure of the project. But first, I wanted to show you a complete implementation of a very simple, fast MCP server. And here you can see that the first thing that you need to do is to create a fast MCP instance. This is very similar to what you get into a fast API application. Here you need to specify a name, a host. In this case, we are using localhost, then a port and an SCC path if we are going to be using the server-side event transport that is going to be available. By default, this is /SSE, and based on this, you can create the server. And for this server to be somewhat useful, we're going to be using a single tool called list tasks. This tool needs to be annotated or decorated with mcp.tool. And this tool is going to be getting a single parameter called max results, and is going to be returning a list of strings that are going to be the tasks that we're going to be providing. Of course, we have a very dummy implementation in here that just filters this stubs list inside. And in order to run everything together, you need to call into your main part of the script, if you're using a script, mcp.run, and then specify the transport, which by default is an stdio or standard IO. In our case, I'm going to be specifying the server-side events in order to run this together. Okay, so in order to run this, I need to actually be into the project root. I'm using UV, so my virtual Python environment is already loaded. And in order to run this, I'm going to be using examples.server.py. Once you run this, you can go through the UV core instance. And if you go to localhost/SSE, you will probably get something like this. You will see the event, which is an endpoint, a data with a session ID. And from time to time, you're going to be getting these ping requests that are probably checking the health of your server. So not much to see right now. But luckily for us, MCP provides us with a very nice implementation that works with an inspector for the MCP instance. And if you run MCP dev examples and then the server, this will start another server that you can visit on localhost port 6274. When you visit the URL, you will be greeted by the built-in inspector, and here you'll note that the URL is exactly the server that we have connected to, along with the SEC at the end. And once I connect this, you see that we have resources, prompts, tools, ping, etc. Of course, our very simple server has only tools, and if you click here and call this list tools, you see that we have this single tool that we have added. And in this tool, we have a single parameter called max results. Of course, this is very similar to what we had into our server implementation. And here, for example, I want this to return just two tasks, and you see that you're actually getting the response back. Let's try it out with a single parameter, and you see that again this is doing the calling to the server. So we've built the server, but how do we connect to it with our own custom client? I'm going to show you just that in a bit here. Let me clear those instances. And let's go through the client for our application. So one important thing here is actually that you need to be providing a client that is working in an asynchronous environment. So what do you need to do in order to connect to your server? Let me first come here again and start the server. Here you will need to be calling this SCE client. Of course, we are using server-side events, so this will be the case in our example. And here I have a server URL function, which is going to be essentially building this URL for us based on the host, the port, and then the SC path. So everything of this together is going to be provided as a string to the SC client. And based on that, we're going to be getting a reading stream and a writing stream. Of course, the communication is bidirectional, as we have already discussed. And then you need to be providing this client session, which again is going to be a context. And based on this context, of course, the resources are going to be cleaned up once you're out of this code block. So keep that in mind, that you need to clean up essentially a lot of resources when you're connecting to MCP. And then you need to call this session.initialize. Of course, it appears to be the case that getting a connection to your server is not as straightforward as one might imagine. And then the first thing that we're going to do here is to actually, let me show you, call what are the available tools that we have. Just go through here and let's actually run this Python examples client. And you see here that I'm using reach in order to parse the response. So we have a single tool that is going to be called list tasks. This is the server on the server tool that we have created. You can see here that we have the description that is taken. Let me go actually to the tool. This is the description that is essentially matched to this documentation that we've provided. And based on this, we also have an input schema, which is something that is very similar to your two definitions that you have within your LLMs, if you're familiar with that. The first thing that you can see here is that we have a single property called max results. It has a title, which is called max results, and it has a type of integer, which is essentially provided right here. So typing definitions probably would be very efficient here. And we have a list of required parameters. Of course, the max result is required since we didn't provide a default value for it. And then we have a type of object for the input schema. So this is what we got for the list of the tools. And now let me show you how you can actually call this tool. You essentially need to call this tool. Let me actually comment out this. So you need to call the call to method on the session, define the tool that you want to call. Of course, this is mapping to this. And then the arguments, in this case, max results equal to 2 in a dictionary. And since this is an asynchronous call, you need to be calling for the response for the session. And then we're going to be printing the content of that. Let me run this again. Let me make it a bit clear for you. And here you see that we got the text content in a list, and this is the type of the response. And we had the two tasks: eat breakfast and then go to the gym. So this is the list that we have provided. And let's see what happens if I go through here. You see that we are now getting the list of all tasks that we have. Now that you know the basics of how you can build a very simple MCP client and a server, we are going to go through the integration of our AI agent using the MCP server that we are going to be building. First, I'm going to give you a very slight overview of what is the configuration. Here, I'm essentially going through how I'm going to be setting up the LLM. In our case, I'm going to be using Qwen 2.5, and I'm going to slightly increase the context window for the Ollama server. Also, I have essentially the configuration for the MCP server along with a maximum number of iterations that our agent is going to be making. The domain logic for our application is going to be a to-do app. So in our case, we're going to be having just a single domain model, and this will be the task. This task is going to be very, very simple. I will have just an ID, a name, and whether or not this task is completed or not. Of course, I will also have this task manager that is going to be essentially the controller or the manager for all the available tasks. Of course, you will probably need to have a database or some other way to store the resources of your application. So here, the task manager, again, very simple. It will contain just a list of tasks. It will have a single get tasks method, add task, and we'll be using our internal generate ID, essentially incrementer, in order to get the next ID for the task. We will be able to remove a task and then mark a task as complete. Our MCP server for the to-do list application is going to be pretty simple. I will have the instance of the fast MCP, and then I'm going to be creating this in-memory task manager instance with a set of stopped tasks. And essentially after that, we will be able to get a tool out of each task manager method. Here we have the one for get tasks, the add task, and note that after each tool, I am actually calling the get tasks. So after the operation on the task is complete, we are going to be essentially calling the get tasks function. Note here, for illustrative purposes, I have essentially limited the ability of adding a task to just the name. I skipped on the is completed part. You can, of course, try to add that on your own. Then we have the remove task and then the complete task. And of course, these are going to be, again, providing the necessary code to the task manager. And then a very simple run of the transport again, which is going to be the server-side events. At this point, you can start your server and try to play with it using the MCP inspector as I've shown you on the simple server. But the next step is to actually now focus on the client side. And here we will need these two additional functions that are going to be provided by our AI agent. That is going to be the call-to function and then the what-tools function. Here I'm pretty much using the Ollama and Langchain implementations for this tooling support. And you can see that I'm adding this tool message import to call, and then essentially I'm going to be creating a structured tool for each instance of an MCP tool, and I'm going to show you how I'm doing this. Most of the code that I'm going to show you here for the mapping itself is taken from the Langchain MCP2 adapter, but this adapter, at least in my opinion, is a bit more complicated that we need for this application. So I essentially took some of the code and refactored it a bit in order to be a bit simpler to understand by us. And here, the first thing that I have is the call to. This will accept a tool call along with all of the available tools that we have. And this will actually get the tool by its name and then essentially use the asynchronous invocation for Langchain and call the tool itself with the arguments that the agent is going to be providing for us. And then this is going to be return a tool message with the content as a response from the tool call, and then the tool call ID itself. So essentially, this will be the function that our agent is going to be calling when it decides, for example, that it needs to mark a task as complete. And then this will be the response received by the MCP server. Also, I have this what tools, and this is essentially where the magic or mapping between the client and the server tooling happens. So we have this function or method that I've already shown you called list tools, and this will return a list of MCP tools. And based on these tools, I'm going to be essentially creating this convert MCP to Langchain tool. And let's go through how this is happening under the hood. So for each tool from MCP, we're going to be creating this structure tool, and I have already shown you the structure that the tool or what tools have. And first thing that I'm going to do here is to get this name of the tool, the description. This is essentially going to be the doc string that you're adding to your tool, the input schema, which is going to be the parameters and arguments that you need in order to call this tool in itself. And then we have this coroutine, which essentially is going to be the function that we need to call in order to run this tool. So what is happening here is essentially get the result from calling a tool using the session that is passed in. This is the client session from the MCP instance. We're calling the tool with tool.name and then passing in the arguments as I've already shown you on the simple client. And then I'm going to be calling this function, which is going to be called convert call to result. So again, this first is going to be checking for an error and then converting the result essentially into a string. Check if this is an error, raise a tool exception if this is the case. And then after that, I'm going to be essentially filtering out the results by those that are only a text content, since our agent is going to be able to work just with text. And if you're, for example, using audio, images, etc., you need to expand the part right here. And then I'm going to be checking if the result is just a single item within the list, then I'm going to be returning just the string for that. And here you can see the output or the result type. is just a string or a list of strings. Otherwise, I'm going to be going through the text contents and then returning the text for each one in a list. Now that we have our to mapping, we can go through the agent itself. Here you can see that we are calling this function that we have just created called call2, and this is going to be useful for our agent. This is essentially the prompt that I'm going to be using. What I go through this prompt is something very similar to what I've discussed into my previous video on the new prompting rules. Here I'm specifying all of the available tools and why and when each tool should be specified. I want to be using an emojis for the completion status and for essentially a white square for tasks that are not complete. And I have also added some more instructions here. Of course, I'm going to be using Qwen 2.5. So based on that, I will provide just two client-facing functions here. First is going to be to create a history of messages, and this will include the system prompt that I've just shown you. And the next one is going to be essentially the agentic loop that is going to be provided by the application itself. So once we are asking the agent to do something, I'm going to be logging this into a user request. And once this is complete, I'm going to be getting the history, I'm going to creating a copy of it and adding the user query within that. Then I'm going to be starting a while loop that is going to be limited by the configuration of max iterations, so that I'm pretty sure that our agent is not going to be stuck forever within this invocation right here. And after that, I'm going to be using the invoke, which is the async invoke on Langchain. Of course, this function is going to be also asynchronous. And once we are getting the response from the agent, I'm going to be adding the response to the messages. And if we don't have a to call within a response, I'm going to be returning this as the output of our invocation. Next, I'm going to go through the to calls that we have. And for each one, I'm going to be calling a walk that I'm going to be presenting to you of what is logging under the hood. After that, I'm going to be using our call2 function, and to it, I'm going to be providing the to call instance along with the list of the available tools that we have. I'm going to be waiting for the response and then adding the response to the messages over here. And once this is complete, I'm going to be incrementing the iterations counter. And if I'm going to go through over this loop, I'm going to be raising this runtime error in order to check whether or not this agent is actually too slow for our application. To connect everything together, we will be using this helper function connect to server, which is going to be essentially a context, since this context manager is going to be asynchronous due to the SC client and client session. Here you see that I'm initializing both and calling the session initialize, and then after that I'm yielding the session, so our context manager or user is going to be able to get just the session out of this block and make using this a bit more simpler. To tie everything together, I'm going to be using a very simple Streamlit application. Here you see that I'm using the connect to server function that we have created. And within that, you see that this is going to be essentially the main function that we're going to be using in order to work with the MCP server. So within here, you see that first we are loading the tools based on the session. Then we are binding the tools to the LLM that I'm going to show you how we are going to be initializing that in a second. And then based on that, I'm going to be calling the ask function with the user query, the history, the LLM, and then the list of tools. Of course, you might prefer to build this into a class to be a bit easier to work with, but this is the function with the 4 different parameters. And then based on that, I'm going to be returning the response from it. And again, this is an asynchronous function. So in this case, in order to make everything work together, I'm using the next async IO. And this will essentially synchronize the threads between the Streamlit application and the thread that I'm going to be using for connecting with the MCP server. Then I have a very simple, let's say, beautification of what is happening under the hood of the app. And then we are initializing our LLM. Again, this is going to be a local instance of Qwen 2.5. And I'm initializing the history again for the application. After that, I'm going to be providing the chat messages that are available within the history. I'm going to be skipping the system message, and otherwise I'm going to be presenting either the human or the AI assistant as the message history. And then for the input, I'm going to be getting the prompt from the user. And once we get this prompt, I'm going to be presenting the loading message. And then here is how I'm going to be running the async IO and get the response from the assistant, provided that I have the prompt, the history, and then the LLM that we have already initialized. And then once I have the response, I'm going to be replacing the loading message with the response from our agent, and then adding this to the message history. To run everything together, you need to first start the MCP server and also have a local Ollama instance that is already running in my case. And I'm going to be just starting the server here. And then on the other side, I'm going to be using Streamlit run streamlit.py. This should start the Streamlit application with the UI that we have just built. And let's start with something simple. What are my tasks for today? And this is the response that you get. Okay, let's continue with something a bit more interesting. Add a new task for meeting with Michael for dinner. Okay, so you can see that the task was actually added to our list. And if you go back to your editor instance and the login here, you see the user request. That is the first request that we have given. What are my tasks for today? And here you see the tool call that we are providing, list tasks, and then ID type tool call with no arguments. And then for our second request, we had add a new task for meeting with Michael for dinner. And this is the tool call, add task, arguments, name, meeting with Michael for dinner, along with ID and the tool call. So essentially, this is what is happening under the hood when you're calling your MCP server with the tools from the AI agent. So this is it for this video. We've seen how you can build a complete MCP application and how you can connect to it using a local AI agent using Ollama and Langchain. You've also seen how you can wrap everything together into a Streamlit application. And if you want to get access to the complete source code, a text tutorial, and the whole ML Expert bootcamp, please consider subscribing to ML Expert Pro. Also, we're going to be having live bootcamp sessions between May 9th and 11th. So this is also going to be available for ML Expert Pro subscribers. Thank you for watching. Please like, share, and subscribe. Also, join the Discord channel that I'm going to link down into the description of this video. And I'll see you in the next one. Bye.